Hi, I'm Igor, founder of Solvi, and in this video I'm going to show you a major update that we have done to our prescription tool. So the prescription tool makes it really easy to create prescription files for different types of variable rate applications, and historically it only supported one scenario, so creating the prescription files based on one of the vegetation indices, so primarily that would be useful for fertilizer applications. But in this new update, it now supports also outputs from PlantAI, which means that the prescription files can be used for spot spraying by using the results of the weed detection, or it can also be used for fertilizer applications in specialty crops. So we can use the size of the plants as an input, we can use plant density and a few other variables. So let's have a look at a few examples. So we'll start with a prescription file based on a vegetation index, which is useful for variable rate fertilizer application. And here we have an oil seed rape field a few weeks after the emergence. And we want to create typically a prescription file to adjust the rates based on the canopy cover of the field. So we want to put more fertilizer in areas with less dense crop and less fertilizer in the areas that already have good crop establishment. So to create a prescription file, we will just click the new button. And here choose the source of the data that will be used for the prescription file. So in this case, it's going to be based on the vegetation index. Here in this new version, we can have more control over how the grid is created. So we can, for example, rotate the grid so that it matches the driving direction of the tractor. We can set the working width of the grid, and now it doesn't necessarily have to be like 5x5 or 10x10 cells. We can set the length and width of the grid cells individually. So in this case, the working width of the machinery is 24 meters, and the height of these grid cells can be, for example, 10 meters. So after we adjusted the size of the cells, we want to make sure that they align nicely with the trim lines. So I'll switch over to the drag tool and drag those so that these edges of the cell go along the trim lines. All right. And after we've done that, we can select a vegetation index that will be used for the prescription file. So here we have a few to choose from. This is RGB dataset, so only RGB indices are available. For multispectral indices, we would have indices like NDVI or NDRE, which can be more robust for fertilizer applications. Let's choose a GLI index in this case, and as we do that, we get this plant health map, which highlights the variations in the field. And from here, we simply need to click Create Prescription button, and in a few moments, a similar map, but now based on the size of the grid cells that we specified in the previous step is created. And the final step that we need to do is just to specify the rate. So in the zones with lower index values, we probably want to put more fertilizer. In the middle zones here, we want to put less fertilizer. And in the zones that are already good, we want to put even less fertilizer. Here we get a nice summary of the total amount that will be used and the average for the whole field. We can also name our prescription in cases where we want to create a couple of prescriptions for the same field so that we can easier differentiate between the different prescription files. We'll leave it as it is in this case and just click Save. So now this prescription is available over here, and to actually download it and put into the machinery, we'll go to the Export tab, choose the prescription section, and here we can also now choose a few different formats. So it can be a generic shapefile as it was in the previous version of the tool, but now we have also added 3 more vendor formats, and more formats will be added down the road. So if we would like, for example, to use it with John Deere machinery, we'll simply click John Deere option here and download the prescription file. All right, so that was the first example. Now let's look at another use case. So it will also be a prescription file for variable rate application, but in this case, it will be in lettuce crops. And in lettuce crops, growers want the plants to reach certain size. So if the plants are smaller than they should be, more fertilizer can help them catch up to the bigger plants. So in this case, we would like to create a prescription file based on the size of the plant, and this data point can be generated using PlantAI tool with the counts with plant level data option. So here we can see the results of the plant counts that was done in this field, and then for every plant in this whole field, also the size was generated, so diameter and area of the plants. And we can clearly see that in some areas the plants are much smaller than in the others. So that can be a good data point to use for the prescription file. We'll switch off the plant counts tool and create a new prescription file. So similar to the previous example, we now can control how the grid is created. So we will first rotate it so that it aligns with the driving direction of the machinery. We will also set the working size. So in this case, it's 3.52 meters. And we will drag the grid so that it aligns with how the tractor drives along the field. So this seems to be aligning nicely. And we can leave the height of the cells at 5 meters. So the rate will be changed every 5 meters as the tractor drives through the field. All right. And then in the next step, we will choose the data source for the prescription file. So in this case, it's going to be PlantAI detection. And in this case, we will also choose detection 1, which gives us this preview of all the counts that were counted. And here we want to choose then which metric the prescription file will be based on. So in this case, we will choose the average diameter of the plants. But a prescription file can also be based on the plant density, so number of plants per hectare. Could be, for example, useful in cornfields for replanting applications, or it can also be based on the canopy cover. So let's choose the average diameter option, and then simply click Create Prescription. So this is going to take a couple of moments. And what's happening behind the scenes is that for every cell of the grid that we've created, the average diameter is calculated. And in the next step, we will be able to set the rate based on the average diameter in each grid cell. Now the prescription file has been generated, and we get this map that shows us how the size of the plants varies throughout the field. So here by default, we have 3 different classes that we can classify all the plants into. But if we would like to, we could create just 2 classes, for example, by removing one of the categories and then setting the slider to the size that we want to be the threshold. Or we can create more classes, for example, 4 different classes. So we would send everything below 14 centimeters would be small plants, everything below 14, 16 would be medium-sized plants, and then we can have another medium category here, and then everything above 18 centimeters would be large-sized plants. And then according to that, we can specify the different rates. So more in poorer areas and less in the good areas where the plants are already big. And then we will just save this prescription file, and similar to the previous example, we then just need to go to the export tab and choose the right vendor format and download the prescription file. All right, and then finally, let's look into another example, a prescription file based on the weed detection that can be used for spot spraying. So in this field, we have sugar beet plants, and we have small patches with weeds here that were very accurately detected by the PlantAI tool. And based on these detections, we want to create a spot spraying map so that only these small patches are sprayed. And as we can see in this specific field, only a smaller part of the field is infested by the weeds. So the growers can make huge savings on spraying just the affected areas. So we'll click the new button to create a new prescription file. We will also choose PlantAI detection in this case and choose detection 1, which is our weed detection. As a next step, we can also align the grid with the driving direction of the machinery. And we can choose the grid cell size. So in this case, it's really important to target this weeds as accurately as possible. So we want to set a grid size to something much smaller than 5 meters. So for example, 0.5 meters or 50 centimeters. And that will depend on the accuracy of the sprayer, of course. So that looks nice. And now we just need to create a prescription file. So now for every grid cell that overlaps a weed patch, the tool will create a spray cell, and all the other cells that do not overlap any weeds will be no spray cells, so they will be simply omitted from the prescription file. Okay, so now we've got this updated version of the map, and it also only now shows us the cells that overlap any of the weed patches, and we can see that only a tiny percentage of the whole field, so just 1.3% of the whole field, has weeds infestations. So we can spot growers can save a lot of chemicals by not spraying all the unaffected zones. So finally, we just need to set the rate for the prescription file, save it, and then export again in one of the preferred file formats. So that's pretty much it. I hope this gives a nice overview of how the new prescription tool works. If you are interested, make sure to give it a try and see how it works in your specific situation.